Hello everyone. From the second derivative video, we discussed the chain rule. Now with integration, we have the opposite of that, or U-substitution. With U-substitution, we'll be doing the opposite of the chain rule. If you remember from the chain rule, we have three types of functions: e to the x, a function in parentheses, or a trigonometric function. With the chain rule, we always had to define an outside function and an inside function, where we took the derivative of the outside function and multiplied it by the derivative of the inside function. We'll be doing the opposite here. For example, if we took the derivative of e to the 3x, we would end up with 3e to the 3x. Now we need to work backwards. How do we get rid of this 3? Well, we need to set u as our inside function. Then we need to take the derivative of u with respect to x. After that, we need to substitute what we get as du with respect to dx back into our function. After that, we can integrate. Let's take a look at an example. If we have the integral of 3e to the 3x dx, what will we get? Well, first, we need to set u as the inside function. Our inside function for this is 3x. Then we will take the derivative of this with respect to x. Using the power rule, this is just 3 dx. We see a 3 dx here, we see a 3 dx here. Keep in mind, we're essentially trying to take this integral and replace it with everything in terms of u. Our u will go here, and our dx will replace 3 dx. We can rewrite our integral as the integral of e to the u du. We know this integration, it's just e to the u, but now we need to plug in back to our x. Because this is an indefinite integral, we need to add a plus c. Let's take a look at an example with parentheses. What if we have something like 3x to the 6x squared dx? Well, we take our inside function as u, and then we take the derivative of this function with respect to x. Now notice in our function we have an x dx, we have an x dx, but here we have a 3, and in our du we have a 12. We need to get rid of this 3x dx entirely, so let's solve for it. 3x dx. In order to get a 3x dx from a 12x dx, we need to divide both sides by 4. So 3x dx will end up being du over 4, and when we substitute this, we'll end up with u du over 4. Now we can integrate this. This is just an inverse power rule. This will be u squared over 2 times 1 over 4th, which will give us u squared over 8. We plug in our x for u, and we'll end up with 6x squared all over 8. Let's try one more. To do something with trigonometric functions, if we have the integral of x squared times sine of x cubed dx, what is our integration? Well, we see that this is U-substitution. It's not just a power rule, and we have a function inside another function. So we set u as our inside function, which is x cubed. Then we take du with respect to x. This is just a power rule, and it becomes 3x squared dx. From here, we're trying to replace everything with x. We see an x squared, we see a dx, we see an x squared, and we see a dx. However, we have an additional 3, so to only have the x squared dx, we divide both sides by 3. That means that x squared dx should equal du over 3. From here, we can replace our integration with sine of u du over 3. Now, to figure out the integral of sine, let's look at what the derivative of cosine is. We see the derivative of cosine is just negative sine. So to work backwards, the integral of sine should be negative cosine. And from here, we replace everything in terms of x. And because this is an indefinite integral, we must add a plus c. That's about it for integrals.